So check this out. This is Flywheel store energy storage technology being implemented in the commercial industry, not in the United States.
Stornetic, the energy storage company. The future requires an optimal utilization of energy and secure access to environmentally friendly electricity. Here at Stornetic, we support a better electrical power supply. Stornetic is a driver of innovation and as such offers demand-oriented energy storage solutions with flywheels. They are manufactured using the latest production methods with the support of extensive experience with high rotation rotors and tested safety concepts. With it, electric energy can be stored efficiently, quickly and consistently as mechanical energy or fed back into the grid. Stornetic, a European company. With N-Wheel, we set new standards. We make use of one of mankind's oldest tools and optimize it for an entirely new purpose, the storage of electrical energy. The N-Wheel consists of casing, a carbon fiber rotor, a motor generator unit, and a solid base. Speed is the key to efficiency. The carbon fiber flywheel accelerates to 45,000 revolutions, hovers wear-free, held by magnetic bearings inside a vacuum. Electrical energy drives the flywheel up to highest speed. The so-called stored kinetic energy is transformed back into electricity with minimal waste. The flywheel storage can be loaded and unloaded without any aging or wear. DuraStore combines several N-wheel to a system solution. The modular structure allows expansion and the creation of customized solutions at any time.
When it comes to energy storage, our first thought is usually lithium-ion batteries. But what if we went old school? Like just spinning things really fast and capturing that kinetic energy, kind of. The versatility and dropping costs of lithium-ion batteries have made them a popular option for not only consumer electronics, but also grid-scale energy storage. But it's not the only solution that's out there. The often overlooked technology of flywheels has been reinvented and may be a good fit for supporting renewable energy like solar and wind. High power density, long lifetime, high efficiency, and being carbon-free has boosted interest in flywheel technology. But how do flywheels stack up over other energy storage technologies? The world has been shifting from fossil fuels to renewable energy sources in order to achieve low carbon emissions and maintain cheap prices. Both electricity consumption and renewable energy generation have been increasing all over the world in the past few years. In 2018, global energy consumption reached almost 25,000 terawatt hours, and of that, solar and wind only accounted for about 1,827 terawatt hours, or about 5% of the total power generation in the world. Since renewables like solar and wind aren't available 24/7 and can't be turned on and off at any time, energy storage systems need to be placed together with solar and wind farms to make them more widely viable. But why do chemical battery installations get all of the buzz right now? Why not flywheels? I mean, the first question to ask is probably, flywheels? Really? Or maybe actually it's, what are flywheels? A flywheel contains a dual-function electric motor to store and generate energy. It operates like an electric motor in an EV to speed up the flywheel using electricity, so that kinetic energy is stored in the spinning wheel. Then when it's turned off, the dual-function electric motor operates like a generator, and the mechanical energy stored in the rotating mass spins the generator's rotor, producing electricity. It's similar to how regen braking works in an EV, but when it comes down to it, a flywheel can be considered a big mechanical battery. To get a little nerdy for a second and talk about physics, the rotational energy of a rotating mass is directly proportional to the moment of inertia, or rotational mass, and angular velocity. That's a lot. For example, imagine that you spin two car wheels of the same mass. Which one will be harder to break? You probably guessed the faster one. That's an example of angular velocity at work. Now let's say one of the wheels is 5 kilograms and the other is 10 kilograms. You speed them both up to the exact same velocity, so they're both spinning at 30 kilometers per hour. Which one will be harder to stop this time? If you guessed the heavier one, you got it. And that's an example of rotational mass at work. Optimizing the shape and increasing the rotational speed will boost the energy that's stored in a flywheel. However, speeding up the flywheel increases centrifugal forces it's subjected to, and the resistance of the material that it's made from limits the amount of energy a flywheel can store. The bottom line is, spinning a flywheel too fast can completely break it apart. Now that's obviously something you want to avoid, As I mentioned earlier, this is something we've been trying to master for a long time. Flywheels were first used in potter wheels and spindles in ancient Mesopotamia to produce threads. Later, they played an important role in the Industrial Revolution, when flywheels were used in engines and machines to smooth out the power delivered by the driving device. However, the first flywheel used exclusively for energy storage was built by John A. Howell in 1883 for a military application.
So one of the things that I've learned is that all engines incorporate flywheels because they are crucial to the operation thereof. So if you're going to make a electrical engine motor generator, one would have to incorporate a flywheel to amplify the mechanical energy being applied and overcome the load of the generator.